Welcome to this explainer. Okay, so today we're diving into something we've all probably struggled with, taming Google Takeout. If you've ever tried backing up your Gmail, you know exactly what I'm talking about. Google hands you this absolutely colossal archive file that basically contains your entire digital life. But there's a huge catch. It is completely unstructured, incredibly unwieldy, and essentially useless in its raw form. You can't really search it, you definitely can't analyze it, and you certainly can't ask it questions. But today, we're going to look at a brilliant technical approach from our source material that actually transforms this chaotic data dump into a highly structured AI-ready knowledge graph. It's pretty amazing. To figure out how we actually solve this modern data headache, we kind of have to ask a wild question. What on earth does an AI logic language from 1972 have to do with your Gmail inbox? Sounds like a total stretch, right? But honestly, bridging the gap between a mundane, static email archive and the elegant computer science of the 1970s is exactly how we unlock the hidden power of this personal data.
Which brings us to Section 1, the logic of email. We're going to look at the theoretical foundation of turning that unstructured mess into a queryable knowledge graph. Because this isn't just about saving files, it's about building a fully deductive database. Our source material actually anchors this whole concept with a brilliant quote from Peter Flock's 1994 book, Simply Logical. He said, "Reasoning forms an integral part of any form of structured knowledge." Floch was showing us how to use the programming language Prolog as a knowledge graph language, literally 2 decades before the term knowledge graph was even a buzzword. The core idea is treating your data as basic facts and searches as logical deductions. So an email isn't just a block of text anymore. It's a structural node in a graph. Its sender, its recipient, and its thread ID act as the lines or arcs connecting it to the rest of your digital universe.
And what's just absolutely fascinating here is seeing how these vintage concepts map perfectly to the modern closure and data-driven architecture explored in this project. Flatch's ground facts, those logical links, literally translate into data-driven datums, which turn emails into nodes and addresses into connecting arcs. The project takes the recursive logic rules of the past and uses them to execute lightning-fast data log queries today. And the best part? This gives the system guaranteed termination. That means the logic won't get stuck in some endless loop, and it uses set-oriented semantics that automatically deduplicate the results, so you literally only see exactly what you need. All right, moving on to Section 2, ingesting the mbox monster. Because before we can do any of that elegant, logical deduction, we have to deal with the giant, monolithic mbox file that Takeout spits out. Now, if you've ever tried to open a 10 GB text file, you already know it's going to crash your computer. So this project uses an ingenious zero-copy file splitting trick that works right at the byte level. It doesn't even try to load your whole inbox into memory. It just reads raw bytes, scans forward for the exact standard message boundary, which is simply the word from, followed by an @ symbol, and splits the file cleanly right there. It literally chops the monster down to size without corrupting a single message or accidentally interpreting random binary attachment data as a new email. And that brings us to a crucial number, 500. The tool automatically caps these split chunks at exactly 500 megabytes. But why? Well, the underlying parsing library, MIME4j, uses memory-mapped files that have a hard limit of about 2 gigabytes. By defaulting to 500 megabyte chunks, it safely stays way under that ceiling, gives the system plenty of headroom, and ensures every single email is preserved perfectly during the ingestion process. So now that our data is safely ingested, we hit Section 3, Smart Label Propagation. This is where we go from raw data to the real magic of logical inference in our newly minted knowledge graph. Think about how we use Gmail labels. They are great, but man, they are incredibly sparse. You might manually tag one email in a massive thread with taxes 2023, but the other 20 replies in that conversation just sit there untagged. If you search for that label later, you only get a tiny fraction of the context. Well, label propagation is the automated process of inferring and applying those missing labels based on thread connections. If any email in a thread has the label, the system can logically deduce that the rest of the thread should absolutely inherit it. This comparison brilliantly shows the difference. On the left, an unpropagated thread is totally fractured. Maybe only one email out of 6 actually has that treating tag. But on the right, through the magic of this data log graph, we get a union of labels applied dynamically. All 6 emails inherit the tag. Suddenly, your search results give you the complete conversation, providing total context instead of just a fragmented little snippet. Now, for the technical folks watching, you're probably wondering, okay, how expensive is this to run across hundreds of thousands of emails? Well, good news, it's O of N. This powerful inference operation runs in linear time. It scales perfectly with the number of labeled emails and their thread members. That means it remains incredibly fast, even if you're processing a decade's worth of thousands of emails, completely avoiding any nasty processing delays. All right, let's jump into section 4, querying your knowledge graph. This is where we hit that, wait, it can do that factor, looking at how this purely local database suddenly reaches out and interacts with the live internet. Because here is a super frustrating reality of Google Takeout. Sometimes it just randomly omits email bodies and strips out attachments. You're left with nothing but the metadata headers. And let's be honest, a static offline archive isn't very useful if the actual content is missing. But this project handles that flawlessly by integrating with Google's internal environment, specifically a platform called Antigravity and a command line skill called GWS. The workflow to fix this is just so cool because it bridges the gap between your static offline archive and live Gmail data. First, it maps those static standard message IDs from your hard drive right to Google's live internal Gmail IDs. Then it calls that GWS skill to rapidly fetch all the missing HTML bodies over the API. It even downloads those dropped attachments straight into Google Drive. You add in scripts that fetch abstracts from Archive, Markdown files from GitHub, or metadata from YouTube, and suddenly your static archive is completely dynamically enriched. Which brings us to the climax of this explainer, Section 5, AI Analysis with Notebook LM. We've got structured data, propagated labels, enriched content. Now we feed it to the AI. But to talk to an AI effectively, you need a format it completely understands. The project uses a reporting script that formats these targeted email queries into incredibly clean Markdown. The subject gets mapped to a level 3 heading, right alongside a really clean metadata table, filtered URL extractions, and a 500-character preview of the email body. It strips out all the digital noise and gives the AI exactly what it needs to understand the context perfectly. So what's the payoff? You take this beautifully structured Markdown report and pipe it directly into Google's Notebook LM. By doing this, you're essentially transforming an old, forgotten email thread into a highly active, chat-based AI research assistant. You can literally ask it to summarize a 10-year-long conversation with a client. You can reconstruct a project timeline or extract unresolved action items from past negotiations. Because the data feeding it is so rigorously structured and enriched, the AI's answers are incredibly accurate and context-aware. It literally changes how you view your personal digital history. Your inbox isn't just a chronological to-do list anymore. It is a rich, queryable knowledge base waiting to be explored. Which leaves us with one final, pretty provocative question to think about. What hidden patterns, forgotten ideas, and untapped insights are buried right now in your own inbox's knowledge graph? The tools to find out are finally here. Thanks so much for joining me on this explainer, and I really hope this inspires you to take a fresh look at your own data.